Thank you for joining all. Hasha, hello.
Hi.
So let me just explain for those who just joined for the first time, like Dua. Last time we covered the basics of what machine learning is, why it is used for, um, what are the broad types of machine learning algorithms, and today, actually, I wanted to cover the basics. I think you know about the linear regression, but in case you want to refresh what it is and what we aim for in linear regression. And then I want to make sure that every one of you have the environment installed on your computer, or there is a way to use Jupyter in your web browser. So we will look through this. And using Python environment Anaconda, we will do machine learning analysis, and it's also useful if you are joining our Python study jams on Monday, because we didn't do it yet. So let me start with the linear regression first. Any one of you, maybe, who knows what is linear regression and why we use it? Anyone used it in your research? None? No one? So it's just a straight line. And what we want to do is to predict or estimate the best fit line for our data set by minimizing the loss. So today, what we need to learn is to understand what loss is and how do we calculate it, how we draw the best fit line. Let's just see the video first. Okay.
So as we said before, our model is something that we learn from data. Now, there are lots of complicated model types and lots of interesting ways we can learn from data. But we're going to start with something very simple and familiar, and this will open the gateway to more sophisticated methods. Let's train a first little model from data. So here we've got a small data set. On the x-axis, we've got our input feature, which is showing housing square footage. On our y-axis, we've got the target value that we're trying to predict of housing price. So we're going to try and create a model that takes in housing square footage as an input feature and predicts housing price as an output feature. Here we've got lots of little labeled examples in our data set. And we're going to go ahead and channel our inner ninth grader to fit a line. We can maybe take a look at our data set and fit a line that looks about right here, maybe something like this. And this line is now a model that predicts housing price given an input. We can recall from Algebra 1 that we can define this thing as y equals wx plus b. Now, in high school algebra, we would have said mx. Here we say w because it's machine learning, and this is referring to our weight vectors. Now, you'll notice that we've got a little subscript here because we might be in more than one dimension. This b is a bias, and the w gives us our slope. How do we know if we have a good line? Well, we might want to think of some notion of loss here. Loss is showing basically how well our line is doing at predicting any given example. So we can define this loss by looking at the difference between the prediction for a given x value and the true value for that example. So this guy has some moderate size loss. This guy has near zero loss. Here we've got exactly zero loss. Here we probably have some positive loss. Loss is always on a 0 through positive scale. How might we define loss? Well, that's something that we'll need to think about in a slightly more formal way. So let's think about one convenient way to define loss for regression problems. Not the only loss function, but one useful one to start out with. We call this L2 loss, which is also known as squared error. And it's a loss that's defined for an individual example by taking the square of the difference between our model's prediction and the true value. Now, obviously, as we get further and further away from the true value, the loss that we suffer increases with a square. Now, when we're training a model, we don't care about minimizing loss on just one example. We care about minimizing loss across our entire data set.
Okay. So maybe you already know that linear regression is one of the simplest machine learning models. And one example that I can give you from the real research, is my own topic of research. If you attended one of my presentations, maybe you know that I studied the effect of nuclear size on movement of chromatin, the DNA, and to predict whether the change in nuclear size affect the mobility, I used linear regression model to evaluate the X, which is the change in nuclear size, and predict the value of Y, which is the chromatin mobility. So this is the real example of the use of linear regression in your research. So you might, for example, Hashar, you may compare the use of different chemicals on, I don't know, like precipitation or rice growth, I don't know. And so keep in mind that it is the machine learning model, the easiest or the simplest example. And
I think I can use this model to determine the effect of fertilizer amount used on the plant growth, like that.
Yeah, that's great. So knowing different types of model, understanding their application, their use, and how actually you can conduct these analyses will help you to use it in your research. So that's the main purpose of our study jams. So in this example, they use the cricket chirps per minute and the temperature in Celsius. So we want to construct the line. So whatever is on the X and whatever is on the Y axis, we want to construct the line so that we minimize the loss. And as you saw from the video, the loss is the distance between the actual data point and the line. So we want to construct the line so that the distance is minimum. The distance between the data point and the line is minimum. So for example, like this, yeah? And this is the linear relationship, which is written in mathematical form by the linear equation. And usually we use the mx plus b, and they said that we will use W for our machine learning models because W means the weight. And the weight is the same as the slope of the traditional linear equation. And also we should keep in mind that we can have the X with subscript because we sometimes have multi-dimensional data. So this is the main thing that we need to know. And then let's go to our training and loss. So you can see here two examples. We have the data set, which is the yellow circles, and the blue line represents the prediction, the best fit line. And the arrows represent the loss, the distance between the actual values and our line, the linear regression line. So what do you think is the best model among two? What is the better?
Right one.
Right one, yeah. Because why?
Because we minimize the loss. The loss is minimum here.
Yes. So I think you understand what the loss is, and to calculate, we use the definition that to calculate the squared loss, we need to subtract the prediction from the observation and square the result. So let's check our understanding on this. I think it's easier topic for today, but just to make sure we all understand. So we have here two examples, data and best fit line. Which of these two data sets have the higher mean squared error? What do you think? Don't be afraid to just give answer or any ideas. We are here to discuss our thoughts.
Maybe I think the right one has high mean square error.
Why?
Because the two candidates deviate quite higher compared to the first one. Although we have 4 candidates that deviating from the linear regression line, but the difference is smaller compared to the right one, I think. So I think the right one has.
Any other ideas? Are you all agree?
Yes, I agree. I think the light one is light because the linear line is best express the point, and I think the 2 point out of the line is the outlier, I think.
So you think that the right one is the best fit line?
Yes.
So,
yes.
So we have two opinions. So Harsha thinks that the right choice, the right example has higher mean squared error, and because of this, the left line is better. And Tomoki says that because the line on the right represents the majority of data points, the right line is the best. Did I understand you correctly?
Yes, thank you.
So actually, let's recall what mean squared error is. So mean squared error is the L2 loss. Yeah, this is the loss. How we calculate it? We calculate the difference between the actual value and the line, our blue line. So if we calculate the difference between these 4 points, so the difference, the error for 6 points here is equal to 0, right? And here, because the difference is 0. If we sum up all the difference between the data points, 4 data points, and the line, it will be about 1, squared. But here, although we have 2 points, the difference between the actual data and the line is 2. And if we square 2, it's going to be 4 times bigger than the squared of 1, right? So actually, the data set on the right has the higher mean squared error. Do everybody understand this? If not, let's go back and see again the example we had for training and loss. So mean squared error is the error or the L2 loss that we are calculating by subtracting the the actual data value minus the line, the value on the line. Yeah.
I think another important point here to consider is we should consider the mean square error of individual point, not the whole set. Because if you consider the whole set on the right side, the difference is 2 for one point and the difference is 2 for the other. So it's like if you it's equal to 4. And if you consider the mean square error on the left side, 4 points each has one difference, so it's also equals to 4.
I see.
I think because it's squared, so it's
Yeah, please continue.
no, yeah, because it's squared, so the value will be bigger if there are some outlier there.
Yeah, that's the main point. Both the left and right figures have the same data points, right? Number of data points. But although the 4 values on the left are away from the line, we tend to think that the right graph, it has the better fit line, right? But what we need to calculate is not the number of data points, but the distance between the data point and the our line. So if we calculate the difference between these 4 points and square them, it's going to be equal to 1 squared plus 1 squared plus 1 squared is going to be 4. Yeah. And if we calculate the difference between this point, red point, and the blue line, is going to be 2. 2 squared plus 2 squared is going to be 8. Yes.
Okay, I understand.
That's the main thing I think you need to understand from linear regression. So because the right one has the higher mean squared error, it means that the best fit line is on the left, right?
Yes, I got it.
Yeah, am I correct?
Yes.
Okay, thank you very much for your active participation. And this is it for our machine learning algorithm for today. So we just refreshed our understanding of linear regression, and I think you can now use it on your in your research. And now I want to proceed with the environment installation. So does everyone have the Anaconda installed? If yes, please use thumbs up or just say I have installed.
Yes.
I have installed.
Okay.
Yes.
Good. And if you don't have, let me share.
Sorry, is Anaconda okay?
Anaconda.
Or we will use Jupyter Notebook. Okay.
Okay. Yeah. If not, I will share this link with you. And you need to follow the instructions to install Anaconda. And this allows us to have the environment with Python pre-installed and to install Jupyter. This is where we're gonna run our code. And for now, for today, for this study jam, you don't have to have Anaconda and Jupyter anything installed, because there is another option to run your analysis on the web, and I'm going to share this link with you all, so that you can just start the Jupyter on your browser here. And why I wanted to install the Jupyter to have because we want to study the NumPy, the small tutorial today, which will help us to actually analyze data. Anyone heard of NumPy?
Yes.
Yeah. Anyone else?
Yes.
Okay, good. So it might be easier for you then, but I still recommend you to refresh the knowledge because it's a small tutorial. It's really quick tutorial, and everything that you need to proceed further with our machine learning journey. So please all go to this link, and you see it's very quick, short tutorial. Please open this link and let's just consider few steps that you need to know for this study jam. So NumPy is the package which helps you to work with your data. And the first thing that you need to do is to import this package. And we import this package or module by running the import numpy as np. So we import the package as, and we name it np just for, it's like standard name. So what's good with this collab is that you can run everything on the web. And once it's completed, you can see this mark, or on the bottom, you will see completed. Yeah. Then from our Python fundamental study jam, maybe you know that we have a point method. We call the method using the point notation. So we call the method in the library or the package np that we imported, and this method is called array. This method is used to create the matrix with your values. For example, you can create a variable of any name. Here they created the variable one-dimensional array and called the method array and populated this array, this matrix with some values. And in order to, you know that we call our method and we use the brackets to give the method some parameters, or I forgot again the word starting with a, arguments. So we give it arguments, and we didn't cover it yet on our Python course, but the list is formatted with the squared brackets. So for array method, we give the argument a list, and the values on the list, the items, are separated by comma. So here is float in the list, and to print we use the print function. Yeah, so we can run this cell and we see a list. So we created the variable which is the list. Then we can create a two-dimensional array, and for this we need to use multiple lists on a list. Yeah, so dot array method will require a list in the argument part. Yeah, here. So that's why we have the outer square brackets. And then because this is a two-dimensional array, we will have two items in the list: 6, 5, 11, 7, and 4, 8. Each of them are lists. Yeah, that's why we have another square bracket separated by comma. Let's see the result. And this is the matrix, two-dimensional matrix. Yeah, we have one column and another column. So here, is everything clear?
Yes, clear.
Okay. Do you all can run the cells?
Yes, yes.
Oh, cool. So we can use our data that we have, but sometimes we want to create empty matrix, empty table. For this, we can use the method zeros, or we can initiate the values in our table with ones. For this, we will use ones method. You can try to change here, for example, the method, for example, zeros, and see the result. Oh, it's going to be an error because it's okay, this. Yeah, so we will use the built-in function. Is it correct?
Should we define the size of the matrix?
Yes, maybe like this, for example, yeah? No. Okay, let's see the arrow. We cannot interpret 3 as data type. I see. Like this. Okay, got it. And it has 0, 0 here. Let's try. Do we? No, okay.
Double bracket with comma as separator.
Comma as separator. Ah, okay, we see here. So this is just the hint how we should write our function. We will use zeros, and then we have shape argument, the type, float, and then order. Yeah. So for shape, we will have okay. Okay, I got it. 2, 1. Okay, is it correct? No. I want to create a multi-dimensional array, and let me see. Okay. I got it. Okay, thank you. Thank you, Abdullah. For example, 2 and 1. So first is the dimension, and for example, integer. We specify the type. Yeah, so here we have 2 rows and 1 column. Is it clear for you all? And you can also try with ones. I think it's going to be same. We don't need to have, okay. Like this. Okay. If we have not specified the type, it's going to be float. If we specify the type, it's going to be integer. Yep. Okay. Then let's go further. And then we want to imagine we want to create the list or the table with a sequence of numbers. For this, we will have the method arrange, and this will generate the numbers from 5 to 12, excluding the upper boundary. I think, let's see the example. Okay, so we have 5, 6, 7, 8, 9, 10, 11. Yeah. You also can try your own values here. Okay, let's see another thing. Imagine you have some data set and I don't know, you want to create a fake data set to create, for example, the motion of some particles, to simulate the motions of some particles. And for this, we can use the method rand_integer to create the random numbers with specified low, maximum, and minimum value, and the step size. Yeah. So we will have the first argument, which is the low value, higher value, and the this is not the step size, it's the number of points, I think. Yeah. Let's see the example. Yeah. So we have 6 random numbers from 50 to 100. Let's try another smaller numbers, for example, 0 and 10, and we get only 4 values here, the result. And next, we will try to create random values specifying the range. So if we say 6 is going to be from 0 to, I think, 5. Yeah, let's see it. Okay. I see. It's going to be from 0 to 1 and only 6 values. And you can try your own values here. For example, 10. It's never going to be 0 and 1, I think. Only the float number. And you can apply your knowledge from Python fundamentals. You can use mathematical operations. For example, we created the variable random floats, and we have 10 values, and we want to add 2 to all these values. See, the 2 was added. Or we can use multiplication, division, and other mathematical operations. Then let's do, okay, this is the tasks. If everything is clear, then maybe you want to try yourself, the task 1 and task 2. If you have any questions, let's discuss it. Let's discuss this first task after about 3 minutes. I think it's enough. If you already done, then you can share your answer in the chat or just speak up. Anyone wants to share their answer? Or just discuss how you can, what method you can use to create the data?
I don't understand the second assign 15 values to.
Mm-hmm. Okay, so we 15 values. Okay, so we created the data set of 15 values in feature variable, and we need to apply mathematical operations on these 15 values and save it in the label. So assign 15 values to array, array variable. Array is a list variable named label. It means use assignment operator. So create a variable label that has 15 values modified by the example like this. This is the rule how we should modify our 15 variables saved in feature to create the array variable label. Is it clear?
Oh, okay.
Uh-huh. Okay, Tomoki had already done. Okay, let's wait for 1-2 minutes. So think about what would you use, how would you do it? And share your answers in the chat, or just unmute yourself and let's discuss. So first thing that we need to do is to create integers, a sequence of integers from 6 to 20, including 20. And save this sequence. It's going to be a list array, one-dimensional array, to a variable named feature. And I think you will better understand what array is on our Monday sessions, Monday Python fundamental session. But for now, just understand that array is a kind of list, or it's a matrix, and it can be one-dimensional or multi-dimensional. Because we have integers from 6 to 20, it's going to be just a list, linear data set. Yeah. So the task is to create linear data set. What function would we use to create this data set? So Tomoki suggests to use arrange. Yeah. Let's try.
Yes, that's one.
Okay. And we can comment next lines, following lines, to just quickly check whether we have the data set created. Yeah. Yeah, we have we have a linear data set with integers from 6 to 20. Yeah, so this is correct. Then we need to create another variable called label and apply some transformations to our feature array so that it follows these conditions. Yeah. So what Tomoki suggests is to use mathematical operators, which is multiplication and summation. So we're gonna multiply 3 by our feature array and add 4. So we have our result. Does everybody understand? Harsha, Dua, Devati, is it clear? Asha?
Yeah, a bit.
A bit? Okay, so if you
Yeah.
have any questions or you hesitate, don't be afraid. We are
I tried this one and it worked.
same, yeah?
Yeah.
That's great. Let's try it also. So we can use random. Oh, interesting. Let's see the result. I want to compare the results. Let's save our next feature. It's going to be by Revati, and she introduces a different method, random, and we're gonna have 6. Okay, let's print it. Oi. Okay, we got the same data set, and then she uses the same function. Okay.
I think it should be feature dash R.
Yes. Okay, I see. Yeah, I also saw that random number actually gives us from 0 to 1. I was also curious. So here is the random, okay, here. So this is the method that creates numbers from 0 to 1. And the number in the argument specifies how many numbers we want to get. So when you wrote 6, it means you want 6 numbers. And when you use random method, you create 6 numbers from 0 to 1. Yeah, that's why we have these numbers, and it doesn't follow the task, and that's why if we do the same, we'll get the different result. Yeah, so the correct answer to this task is this one, and it's also correct, but it's not what the task asks. Okay, thank you, Tomoki. Bye bye. And then we have the answer here. We can show a code. Okay, so Tomoki used the low number to specify the minimum number. Then he used the upper number, and he used 1. I think it's to specify the step size maybe. And they suggest just to use 2 arguments without specification. I think because the standard step size is 1. Yeah, and then they also use the brackets to give more details about, I think, the order of operations, but we know that multiplication is has higher priority than summation. Okay, and let's do the task 2. Again, you have about 2 to 3 minutes to do it, and then we will discuss the answer.
Can I ask one thing here?
Yeah.
In the first point, they say that the assigned sequence from integer 6 to 21. I couldn't understand why here 21 is used when it says assign integers from 6 to 20?
Yeah. Good question. Because we want to get numbers from 6 to 20 inclusive, and the method arrange asks two arguments, the lower bound and the upper bound, and the upper bound exclusive. So if you put 21, then it will include 6 and 20, but not 21. So mathematically, we would write this as like this. I don't know. 6 like this. You know, this is the, let's say, the period, including 6 and excluding 21. So it means it's going to be only 20. And
Okay.
yeah. So if we put here 20, we'll see that it stops at 19.
Okay, thanks.
Thank you. Let's do task 2. If anyone has the answer, please share it in the chat, or we can discuss it in 1 minute, about 1 minute, 1 to 2 minutes. If you don't understand the task, also please share it with me. Okay, let's discuss. Any ideas? Any ideas of what do you think? What we are trying to do? What's the purpose? So the task 2 is about adding some noise to our data set. Yeah, so now we have this data set. We have modified these values using this formula. And we want to make our data set more realistic, and we want to add some noise. And to add noise, we first need to create the noise. Yeah. So we need to add floating point values between -2 and +2. And what can we do? We have the lower bound, the upper bound, and we can create random data set, right? So let's try. So Rivati, maybe you know how to create random data set. What would we use?
Random.random.
Right. So the same here. Yeah. Okay. And this will create random points from 0 to 1, but we need from -2 +2. How can we do it? And by the way, how many items should we have? Let's see the task. They say that to be more precise, modify each value assigned to label by adding a different random floating point. So it means we need to add to each value in the label. So we have 15 values, and we need to add different noise to each value. So it means that we should have different 15 values, right? That's why what we state here in the argument.
15.
15, yeah. Okay, it's correct. Yes. Now we have 15 values, random values from 0 to 1. How can we convert it that we get random values from -2 to +2? Any ideas? Think about just mathematically, how would you do it? If you have lower boundary.
I'm sorry to interrupt. Is it okay to use low and high?
Here, no. Any idea?
Okay.
Abdullah?
Random don't accept negative arguments.
How can we transform the lower and upper boundary?
We can multiply.
Yes, we can multiply. Okay. I think we can multiply by 2. And how can we do it for -2?
So if we multiply by 2, we will get values between 0 and 2.
Yeah.
If we want -2, then we can multiply by 4 and then subtract 2.
Let's try it. Multiply by 4, and then so let's check it. So we will have from 0 to 4.
Yeah, and then -2, then we will have from -2 to 2.
Let's print it. Let's check it. I think there must be another way, but let's check it. Okay, minus. Okay, we have 1.5 minus 1 and 8, 1.8. Yeah, so it's within the range of -2 and 2. Yeah, so that's correct. I don't have another method, but if I remember, I'll tell you next time. Okay, so Rivati has another method. Let's try it as well. noise variety, okay, R, and then this is going to be random and int, okay. Yes, yes, yes. So we covered this in the previous example. Let's check it. Okay, -2. Hi. Hi. 2, and then size 15. We need floats. Yes, we need floats. Let's check. I see. So we have only integers here. Let's check whether we can specify floats. Okay, okay. Wait. Okay, here. Random. So let's try to specify the type. We will have the same attributes, and then we'll have floats. Float. It's going to be test, and then we will print it. Float. It can be because we use integers here. Yeah, maybe that's not correct. Yeah, it's not correct. I see. Type. Yeah. No. Keyword type. So I think the first method is the most easy to implement.
Easy and simple.
Yeah, I think if I come up with another method, I will share with you next week. But I think the first one is the easiest to implement.
Yes, in this one we have to add more and more arguments.
Yeah. But here we just use 2 mathematical transformations. Okay, and once we created the noise, then we can add noise to our values. So our label is going to be label plus noise. Is correct? No. I hope we don't need to use for loop here. Dimension. Okay, we create it, and then we will let me try to first print label if it's saved. Yes, then label. No. Okay. Open could not be broadcast together with shapes. Okay. So it says that we have different one, two, three dimension, I think. Cannot cast on add from float to integer. Well, same kind. Then I will try to do it like this. Okay. Any ideas how can we edit? I don't have one size 1 array. Let me think. Okay. Okay, we have. Sorry for taking some time. Let's see the answer and then compare it. Okay, so they use label plus noise, but we have the mistake somehow. Why is that? Let's see again. Label plus noise. Okay, we don't have mistake right now. I don't know why, but it disappeared. So we just need to sum up all two matrices, right? So it's simple, but I don't know why there was a mistake somehow. So we get 20 because we had here 22. So it created again different minus 0.8. I think it's correct. Yeah, 25 minus 0.6. Okay, so this is it for today. I hope you can study more these functions. I think this is the main thing that you need to do from NumPy. And next week we will cover Panda and then proceed further with machine learning models. Thank you for coming and sorry for taking some time.
Thank you.
Bye-bye.
Thank you.
Thank you so much.